Hello all. In today's session, the topic what we are going to discuss is classification of images using CNN. So till now we have done with the CNN architecture and also studied all the different components which are used in building a CNN model. So today practically we will implement this application of image classification using CNN model. So for that we will be using this dataset, and I have discussed about this dataset which will classify into 10 different classes starting from 0 to 9, which has images of digits ranging from 0 to 9. 60,000 images will be used for training and 10,000 images will be used for testing. So this is the code. We will be importing the sequential layer and import convolution to perform convolutional on two-dimensional data. We will import this convolutional 2D, then perform max pooling, flattening, which will convert data into 1 by n matrix, and you have fully connected layer and then dropout layer. Anyways, about this parameter we will discuss in the next session. So we will be importing all these parameters to build a CNN model, and this will I'll build a model which was already imported. So next, this is my first convolutional layer. So model.add, already I have imported the convolutional layer, so I will add the convolutional layer into the model which was built here. So the number of filters what I am using is 32, kernel size is 3 by 3, strides is equal to 1, padding same. I have talked about this parameter in the previous session. Relu is the activation function, and the input image, size of the input image what I am using here is 28 by 28 by 1. That is, it is of 28 rows and 28 columns, and this 1 represents it is a grayscale image. And the pooling layer is added to this first convolutional layer. So max pooling 2D, and the size of this pooling is 2, 2. This is my second convolutional layer with 64 filters. Kernel size is 3 by 3, strides 1, padding same, activation function. So the output of this will be given as input to the second convolutional layer followed by a pooling layer. Next, the output of this second convolutional layer will be flattened, and those flattened data will be given as input. That is, I will convert data into 1, n dimensions. The output is given as input to the fully connected layer. So the first hidden layer, fully connected layer, I am using 64 units, and this is the output with 10 units, and the activation function is softmax as we are talking about multi-class classification. And this last command, model summary, will print the summary of the architecture what we have designed. So when I run this code, I will get this output, and you can see that you have output shape and also you have parameters. First, let us talk about this output shape, then we will move on to this part of parameters. So you can see that the output of every convolutional layer and pooling layer is a three-dimensional tensor. So it is a three-dimensional tensor with rows, columns, and number of channels. And you have a word called as none here. So this is the first value. By default, Keras will set this value as none, which is the number of images that are being processed, which means that this dimension is variable and will accept any number. And rows and columns and number of channels here. So here the input image is of size 28 by 28 by 1. That input image is given as input to my first convolutional layer. You can see here input image what I am using is 28 by 28 by 1. So that input image is given as input to my first convolutional layer with 32 filters. So 28 by 28 by 1 will be converted to, as the padding is taken as same, there will be no change in the dimensions of the image. So I will have 28 by 28 by 32. Why? Because I am using 32 filters in my first convolutional layer. So you can see here that I have 28 by 28 by 32 as the output of my first convolutional layer. This is given as input to the pooling layer. Pooling size is 2, 2. So 28 and 28 will be converted into 14, 14. The number of channels will be same as I told in the previous session. The image gets reduced in size, but the number of layers or the number of channels will remain as it is. And this 14, 14, 32 is given as input to my second convolutional layer with padding is equal to same. So there will be no change or no reduction in the dimensions of the image. So same 14, 14. Why 64? Because for the second convolutional layer I am using 64 filters. So this 14, 14, 64 is given as input to my pooling layer of 2 by 2. So 14, 14 will change to 7, 7, 64. This is given as input to the flattening where the dimensions are converted as 1, n. So the dimension will be 1, 7 into 7 into 64, which is nothing but 3136. Now these 3136 like this. I have 3136 flattened features that are extracted given as input to fully connected layer, and the fully connected layer, the number of neurons are mentioned in the code as 64. So I have 64 neurons in my fully connected layer. So these 3136 will be connected to each of the 64 neurons of fully connected layer, and this is given as input to 10 nodes. Why 10 nodes? Because it is an MNIST dataset. We have 10 different labels in the dataset. So this is all about this output shape. Now we will talk about the next part of the table, which is called as parameter. So this parameter is just another name for the weight, and we have a formula to calculate all these values in the parameter. So this number of parameters I'll show you here. Parameter is just another name for the weights. These are the things that your network learns, as I already told. How are these parameters calculated? So you have a formula as the number of parameters is equal to filters into kernel size into depth of the previous layer plus number of filters or the number of biases. So applying this formula in this table, you can see that for this formula, how did I get 30 here? I have the number of filters. The number of filters, how many filters I am using here? 32 filters. So I write 32 into, I'll write the formula here, number of filters into kernel size into depth of the previous layer plus again the number of filters. So 32 into kernel size I am using is 3 by 3 into depth of the previous layer. What is the depth of previous layer? Previous layer input image is 28 by 28 by 1. So depth is 1 plus 32. So 32 into 3 into 3 plus 32 will be 320. Now what do you notice here is the output for both the poolings, that is this pooling and this pooling of the second convolutional layer, as well as flattened layer, will generate parameters as 0 because they do not add any kind of parameters. Same is the case with the flatten also. So both the pooling layers and the flattened layer will not add any kind of parameter, hence it will generate 0 here. And the same is the case here. 18496, how do I calculate? The number of filters what I am using is 64. The kernel size is 3 by 3. And what is the size of the previous layer? The size of previous layer is 32 plus the number of filters. So when I do the calculations, I'll get 18,496. Same is the case here. This is the output of what? dense layer. How do I calculate the number of parameters in the dense layer? I have 136 inputs connected to 64 units. So 3136 into 64, these many weights plus 64 biases as we have done in the previous session. So when I do this calculation, I will get this one. 3136 into 64 plus 64 will come into 2,768,000. Same as the case here. 64 units are connected to 10. So I have 64 into 10 weights plus 10 biases. So this will be 650. So when I add all the parameters, the number of parameters what you see here is 2,20,000. So these are the number of parameters which will be learned by our machine. And in MLP model, what we have done in the previous sessions, this was the model summary which was generated when I used MLP for classification of images, and you can see that you have around these many parameters to be learned by the machine, around 6 lakhs parameters, and here only 2 lakhs, that is the number of parameters I have reduced using CNN, thereby reducing the complexity of the model what I have designed. So this is how convolution is CNN model is built to classify the images. So this is the end of today's session. Thank you.